In this recording, we will be going over regression trees and unsampled trees models. In the previous lecture, we talked about classification trees. Now we have regression trees. In the regression trees, it's a quick, because we know that in the regression or prediction model, the target variable or the response variable has to be numerical. We do not use here Gini index because we do not use classification. We use the predicted value. How do we predict the value? By taking the average value of the previous cases that belong to the same terminal node. If you, for example, predict the income or predict the salary or whatever, then you look at the terminal node and you look at how many cases are there, then you take the average of the salaries there or the average of the income there to give the predicted value. And to measure the impurity in the regression tree, we use MSE, which is the mean square error. We do not use the other techniques, that the misclassification techniques or the Gini index, etc. No, this is a regression tree. So we are using the MSE. The higher MSE, the more impure subset. So we are looking for low MSE technically in each terminal node. Also, the performance of the tree is evaluated using many measures, and we talked about these: MSE, ME, MAD, MAE, etc. Everything else is the same as we did in the classification. Identifying the split point is the same thing, but we are using MSE, not the Gini index. And it's recursive partition process. We are going to have the same thing, and we are going to do an example to explain this idea. But we have two problems attached to the classification or a single tree, single decision tree. Number one, having single tree or developing or building or growing single tree is sensitive to data changes. Any small changes in the data is going to have really significant changes in the trees and the results. So any minor variations in the data would lead to having different results. The other problem is the overfitting. Single tree models suffer from overfitting. They fit the training data too closely, but the problem is it's struggling to generalize to new and unseen data sets. So to overcome these two problems, the overfitting and sensitivity to data changes, we have to think about unsampled trees. Unsampled trees, which is very simple concept, we use unsampled trees to combine multiple single trees into an unsample. And this improves the stability and reduce overfitting and enhance predictive performance. And what is the principle behind this? As we said, we are combining multiple single trees to create a stronger tree or a stronger model. For classification, we use majority rule, where the most frequently predicted class from all of the single tree models is chosen as the final classification. For the prediction, we use the average of the prediction from all of the single trees. Sometimes we use the weighted techniques, but this is not in this class. The problem with the unsampled tree models is the visualization. It's not easy to visualize every single tree because we are growing hundreds of trees until we come up with a final outcome.